In this video, we're going to cover building your own driver using the Universal Driver Interface. But first, let's review the architecture of the UDI. This starts with the OAS assembly, which handles all communication to the OAS server. You include this in your project, and then you build your own custom driver code around it. Your custom driver code will communicate with your own devices, APIs, applications, or anything that currently isn't supported by the OAS platform. Once you've built this driver, you then run this within a hosting application. On a Windows platform, this is typically a Windows service, or it could be a Windows application, or anything that can run .NET code. And later when we cover doing deployment to specific platforms, we'll go over how you can run this driver within other hosting applications, such as .NET Core 2.0 console apps, which can then be converted into Linux applications, or they can be compiled into assemblies which can be used in a Xamarin application, which will allow you to roll this into a native application that runs on Android and iOS devices. But for now, we're just going to cover the driver code itself. This will get you started on how to write all of the functions necessary for reading and writing real-time data, setting up your driver configuration in a server, and even configuring tags on the server that you connect to. Now we're going to jump into Visual Studio and I'll show you how all of these pieces fit together. But before we start that, I want to remind you that none of this code has to be written as I'm demonstrating it. You can download this whole project from our website. Now the solution consists of two main projects. The first is the driver and the second is the host. And you'll see that the driver has one reference to it to the OAS assembly. This is the bit that takes care of communications with the OAS server itself. You'll see other references, including the Newtonsoft JSON library, which is just for JSON parsing, and the .NET Standard library, which is the core underlying architecture. You'll also see two files in that project, the weather utils and the driver interface. The weather utils handles communications with the Open Weather Map API, and the driver interface is based on the clean examples that we provide for developing your own driver interface. So taking a look at the driver interface code, you'll see at the top we have an initialize instance fields call, which just creates an instance of a timer, which we'll use in our demo driver. This timer will execute periodically, and then we'll use this for reading data from the API. You'll see the OAS driver interface. That's the instance that's going to be held globally, which is going to be communicating with the OAS server. And then you'll see here we've got the API key and data refresh time. Those are going to be tied to the Open Weather Map API that we've set up. You'll see here the driver name. That's going to be the driver name that you'll see in the configuration application. And then you'll see the driver properties. That's a list of driver properties that are going to be exposed to the configuration application. You'll see other various hash tables which we're going to be using to hold things like the static tag values, the last update time for timestamps for each one of the tags, and then you'll see the flag for in timer routine, which lets us know whether we're in the timer routine or not, so that we only execute it one at a time. So we have code separated into some sections here. We've got the driver section, which takes care of methods for configuring and initializing the driver specific properties. Then you've got the tag section for handling the tag properties and also setting up tags in the server when we connect. Then we've got the subscribe to events, which is used for wiring up the events that get fired by the driver itself. So in the driver interface section here, this is the constructor, and the constructor will then kick off that initialize instance fields. And you'll see from above that all we're doing there is creating an instance of that timer that we're going to be using. And then since we've got this flag for instance fields initialized, we just make sure that we only do that once. See the machine name that's going to be passed in by the host. And then we've got the instance of the driver interface being kicked off right here. We're going to be passing in all the variables that we're getting from the host when it's called. Live data cloud no, the port number, the machine name, and the credentials used for logging into the OAS server. And the next section that's kicked off by the constructor are setting the defaults. Now these are the parameters for the driver, and then also the parameters for tags, so we can even have custom fields for our tags that are associated with this driver. And these next two calls are going to be used for optionally setting up an instance of this driver on our server when we connect, and then also configuring a whole bunch of tags. Now this gives you an opportunity to spin up a whole bunch of tags, connect them to specific properties, and then have data flowing right as soon as that driver connects. And we've got the subscribe to events so that we can start listening to events coming from the interface. So let's dig into the driver section. The first thing is that driver name. So we're just going to be exposing that property so that external sources know what this driver is. And then we've got this driver config, which returns a list of the driver specific properties. Then we've got the get default driver config, which configures those driver specific properties. In this case, we're going to be communicating with the Open Weather Map API, and we need a couple of things for that. The first is the API key. The Open Weather Map API only allows you to communicate and get data if you've got an API key set up, but this property is going to be set up so that you can have your own custom key set in the driver configuration. Next is the data refresh time, and that's how often we're going to be polling against the Open Weather Map API, and that is tied to your account. And if you don't purchase an account, the Open Weather Map API only refreshes data every 2 hours or so. So we're going to hard code that to 7200 milliseconds, which equates to 2 hours. So as I mentioned, not only can we create custom properties for our driver, we can configure an instance of that driver on the server using get driver interface to add. And this is where we can set the values that we want to put on the server as soon as we connect. In this case, we're going to put in that driver name and machine name, and we're going to create a custom string, and that's going to be referenced in other places. So that's going to be the instance of this driver. That's the identifier for this driver. Then the next thing we're going to do is take that API key. Now we can hard code this in our driver, or we can just allow this to be typed in manually once the driver is up and running. And then here's that data refresh time, which we're going to set as well. Then the next thing is the connect method. You'll see we've got a connect and disconnect. The connect will be fired off when we connect to the server. And this is where we're going to be pulling the API key from the configured value on the server. So for instance, if we've got a driver instance, which we've already configured, this is going to pull the API key and hold that in memory, and then the data refresh time as well and hold that in memory. And then once we're connected, we're going to kick off that timer so that we can start pulling against our API. And the disconnect does all of that in reverse. So what this does is it checks to see if we're already connected, and we don't bother firing off the disconnect methods if we're already disconnected. The next thing we do is we shut down that timer, and then we clear out all of the tags so that we're no longer monitoring those tags and updating them. And then we set the flag to say that we're no longer connected. So that's the driver specific details. Now in the tag section, we have methods for configuring driver specific tag properties. But the first part is get default tag configuration. And what this does is allow us to add specific properties that will be exposed in the configuration application for our tags. All of these tags for this driver are driven by a postal code. So we're going to add the postal code field. And then we're going to add the data point. So we're going to mark which data point we're going to be pulling from the API to update the specific tags. And we're going to default that to drawing out the JSON. So when we're adding a new tag, we're going to just default it to JSON, but you can set the data point that you want. And then we're going to also have an optional field here, which is called temp scale, so that if you're selecting the temperature, you can choose which type of scale you want to use for resolving the value. And then you see here in this notation, we're saying to only make this visible in the user interface when the data point is temperature. And you'll see how that works in a bit. So then we return those list of tag properties, and those will be updated in the user interface. Now in the get tags to add, this is where we're actually setting up our own tag configuration on the server. We're going to be injecting a whole bunch of tags, configuring them, and then you'll see data flowing as soon as we connect. So we're going to start with a list of postal codes and a list of tag properties that we're going to be adding. So we're going to iterate through the locations, and then for each location we're going to add a whole bunch of tags, and each one of those is going to correlate to the data point. Most of them are going to use the same configuration, but the cloud cover is going to use a different data type, and we'll set that to double. And we'll also see if the tag name is temperature, we're going to use the temperature scale. So for all of the tags, we're going to have to set the tag name, and then we set the whole path to that tag. So, and you'll see in this case, we're going to use weather.location, and we're going to construct that based on the index. So as we're iterating through those postal codes, it's going to be location 0, 1, and so on. And then dot, and then the tag data point. So this will create a tag group called weather, a tag group called location 0 through however many locations we're going to use, and then there's going to be a specific tag created for each one of the data points. Then there are a few value-specific properties that we're going to configure. There's the data type, which is going to be tied to the D-type variable that we set before. Most of them are going to be using the same, except for, as we show, the cloud cover is going to be using a double. Then we set up the source of the value. In this case, then we use UDI space driver name, and that tells the server that we're going to be using a UDI driver with that unique name. And then the driver interface is going to be tied to that name that we saw before. That's the string, that unique string. That's the driver name dash machine name. Next, we're going to choose the data point that we're going to be tying to that tag, and then we get the enumeration of the data points so that we can get the actual data point that we're going to pass in, and then we pass the data point that we resolved, and then we choose to see if we're going to be using the scale, and we're only going to be doing that for our temperature data point. And we do a little trick here where we say if the postal code contains a comma, we know that it's not a US location, so we'll set the temperature scale to Celsius. Otherwise, if it's a US location, we'll use Fahrenheit. And last but not least, we set the postal code field. And we add all of those tags to the array, and when those get returned, that will configure those on the server. Additionally, we have methods that will get fired when we're adding tags to the server, and we also have a method for when a tag is removed from the server. And then we can handle when a client tries to read the value of a tag synchronously, or multiple tags, by passing in an array of tags. And in this case, what we do is get the tag name, the postal code, the temp scale, gives us an opportunity to conditionally read those values. And then we call our utility function generate tag value to return the most current value of that tag and the timestamp, and return that directly to the client. We also have an opportunity to write values. Now this API is only going to be used to read values, so we're not going to be using that write values, but if you wanted to write values back to your API, this is where you would handle those calls. And then we have the demo driver code, which is going to be where we execute those timer routines, reading the values from the server. So at the bottom, we have all of the methods that are going to be event handlers coming from the server. You don't have to modify that code at all. We're just going to be looking at the timer routine. So within the timer routine, we just make sure that we're only executing one at a time, so we kick out if we're currently in that routine. We also use some sync locks so that we're not overwriting our values if we're accessing it from multiple locations asynchronously. And then we iterate through all of the tags associated with this driver. So we extract the tag items, which is a list of all the properties on the tags. And this code demonstrates how we would use the polling rate if we wanted to. But as you'll see, using this driver, we're going to be overriding that from the global driver configuration. So instead of using a tag specific polling rate, we're going to override that with the driver polling rate. And then we just have a flag that says if it's okay to poll, we get the current value for that tag. And we use our weather utilities for generating that tag value by passing in the tag ID, all of the tag properties, the data refresh time, and the API key. We'll get into that in a minute. And then what we do is we grab the postal code. Then we're going to get a timestamp for when that data was updated last for that specific postal code. Check to see if we have a valid values for marking if that quality is true. We add the value, the update time, and the data quality for that tag ID to an array. And then when we return that array, it'll be updated on the server for all tags in our list. So jumping into the definition of that generate tag value, we'll see how that works. That's within our weather utilities. So generate tag value takes the tag ID, tag items, which are the properties, the data refresh time, and the API key. And what we'll do is we're going to grab the postal code from the properties of the tag, the data point, the scale if that's going to be used, and then we're going to set a variable for the value that we're going to return for that specific tag. So next we pass in the postal code, the polling rate, data refresh time, and API key into that utility function for get weather data, and that will return either cache data or it'll go out and make a call to the API for the current value. And the data coming back will be in JSON format. Based on which data point we're going to be returning for this tag, we choose to see how we're going to parse it. So we can return the raw JSON, the temperature, the weather, which is a description of the weather from specific parts of that JSON. We can get the atmospheric pressure, the humidity, wind-related data, including the summary, the speed and direction, the percentage of cloud cover, the city name related to the postal code, the geographic location in latitude and longitude, and we generate a string for that. And if there's any other value that's requested, we just return a null because it's not handled. So now we can dig a little bit deeper and see how that call is even made to the API. So we look at the get weather data call. So we set up a JSON object to return. And we check to see if a valid API key exists. If not, we return a null. And if we do have an API key, we can start looking at the refresh time. The first thing we do is check to see if the polling rate for the tag is smaller than the driver interval. And the driver interval is going to override everything. So if the polling rate for the specific tag is smaller than the driver interval, we'll just use the driver interval instead. We're going to create some async locks on our weather data so that if we've got multiple calls coming in, we're not in contention. And then we're going to check our hash table to see if we've got a block of JSON cached for that postal code. If we do, we're going to look at the date time stamp on that data to see if it needs to be refreshed. If it does, we'll clear it out of the hash table, or if it doesn't exist, we'll make the call as well. And then this is where the actual call is made to the API. So we're going to create an async HTTP client. We'll make a call to the URL. We'll get the result as JSON, parse it, and put it in cache. And then we'll return the JSON object. This is the URL that we're going to be using for that API. And we've got that parameterized so that we can choose which postal code we're going to use, as well as injecting our API key that's specific to our client. So we'll jump back out to our driver interface, and we'll see that's how we get the value out. And once the value is assigned to that tag, we're going to be populating that tag value and adding it to our array as we said before. Now the driver interface can't work on its own. It has to be hosted by an application. And what we've got here is a .NET Core console application that's going to act as a host, and that'll also allow us to debug this right within Visual Studio without having to host it as a service. And we've got the core driver host, and you see it's got one reference to our project here, which is the Open Weather Map driver. So when we open up that driver host, you see we've got an app settings.json. This is where we get our configuration settings that are going to be passed into the constructor of the driver. So we've got our service node, which is the IP address of the service that we're going to connect to. Live Data Cloud node, if we're going to be connecting through our local service to a Live Data Cloud node that's already been pre-configured. The port number we're going to communicate on. The machine name, which is going to be used to construct our unique identifier for this driver instance. Store and forward, which is a property we're not going to use in this example, but that would allow you to cache data locally if the driver is disconnected, say, from the API, and then bulk pass that up to the server when it's reconnected. And then the username and password, which is used as a credential for logging into the OES server. So in this driver host, we're going to focus on this main program class. You'll see here we've got our default setup for each one of those parameters. Then we've got an app domain property that's set up so that we can more gracefully handle exits when the application is closed. But more importantly, we've got the main, which is fired when this console app starts. The first thing we do is read the configuration from our app-settings.json file so that we can set our properties up that we're going to pass to our driver instance, and then we create an instance of our driver. So we're going to take all of those properties pulled from the app-settings.json, pass it into the instance, and then we're just going to wait for this console to shut down. So it'll stay in memory and it will be running until this console app is killed. So let's give it a shot. We have to make sure that all of our services are running in the service control utility. So we're going to open up the configuration application and we're going to select configure drivers, and you'll see once we start the runtime we have no drivers configured. We have no custom drivers configured at all. Now we go back to our project and we start it up in debug mode, and you'll see once that console app opens up, some debug information will start to be displayed, indicating all of the methods that are firing off during the constructor. Now you'll see that message saying that we're missing an openweathermap.org API key. That just means that in our configuration we haven't set one up by default. And you'll see that when we select localhost, now we've got that driver showing up because we've connected, and that API key, as you see, is missing. So we'll log into the openweathermap.org website, get our API key, and paste it in there. We'll also see when we select configure tags, we've got all of the tags configured as we described. We've got the weather group, and then below the weather group we've got a location for each one of the postal codes that we've set up, and you'll see all of those different tags tied to the different data points. No data is flowing through because we still haven't set up our API key, and you'll see that there's bad data quality, but you can see that even in the temperature, we're showing the temperature scale optionally. So we can log into the website now, get our API key. Once you've created an account, under your API keys, you'll see your own custom API key. Just copy, paste that into the driver's API key, apply changes, and data should be flowing. So let's go over to the tag configurations. As you see, we've already got data flowing in. So for this postal code 10001, we've got a temperature of 34. Check the city name, you'll see that it's showing up as New York. And then if you look at the raw JSON that's coming in, you'll see that's the data that came in for that postal code that we're parsing for each one of the data points. To learn more about Open Automation Software, go to openautomationsoftware.com. And if you'd like to learn more about the Universal Driver Interface, go to products/developer-tools-APIs/Universal Driver. We even have a page describing the UDI implementation using the Open Weather Map at usecases/UDI OpenWeatherMap-Linux. That's because we also show how to deploy this to a Linux device, including a Raspberry Pi. And for some broad information about the UDI itself, you can go to knowledgebase/UDI overview. This is a good starting point if you want to learn more about the UDI, including some technical examples and FAQs.